Hi guys, welcome to the prep project 2 in the series of machine learning. So let's jump into Google Colab. Mhm. So this time what I did was that rather than going directly into Google Colab, I went on to Google Drive. That is where all our projects are saved, and right click here and created a new folder, and I called it as ML projects or prep projects, whatever you can call it. So expand that folder, and this was the first project which we did previously. So here only I can right click and expand it to more and Google Collaboratory. So this will be our second project, and once again we are going to use a simple linear regression where we will have one independent variable and one dependent variable, and we'll try to recreate the same ML algorithm using the same ML algorithm. We'll try to create a prediction table. Okay, so let's jump on here. So I'll try to call the same name, simple linear regression project 2. So I'll call it a simple linear regression project 2, and you need to save it so that it can reflect on your Google Drive. Can you see? That's good. Now the data which we will be using is from the Kaggle. I will provide the link. Also, I'll try to upload this data onto my GitHub so that you can download from GitHub. And it's from Kaggle. You can search for student study R version 2. So if you not select it, how can you select it? Just go to Kaggle and search for student study R version 2, and this will be the first data. Okay, you can click it and download it. Right now, once you download this data, so let's jump on to the folder. It's in downloads. I will show you the data. It is a very simple data because it's a CSV file. It will launch Excel, and where we can check our data. It is the independent variable is the number of hours you studied, and the target variable or the dependent variable is the scores. So let's suppose if you worked for 2.5 hours, you studied for 2.5 hours, you are expected to get 21 score. Guys, this is all in reality. Nowhere you can say that only one variable will have an impact on the target variable. But as we are learning, we are working on a simple linear regression. We are going for only for two variables. One is dependent, the other one is independent, and the other one is dependent. So this is the data. So let's jump on here, and in the ML projects I created one more folder called dataset. Double click it. You can drag and dump the data here. Now it's there. So once we have the data, then we can jump back to our Google Colab and start working. The first and foremost important is importing the libraries. So I can put import. I'll try to expand it to so that you can see 125. That's fine. Import numpy as np, import pandas as pd. As I said that I'll be soon launching a series on numpy and pandas libraries where you can understand more in depth about that libraries. Okay, now matplotlib dot pyplot as plt. Right, also what I'll do is that I'll try to I'll run this, execute this line. So you can click shift enter, you can run this cell. It's taking a bit time. Yeah, it has executed. Now I'll click on text and I'll move this text line up and up. Can see? Now double click this line on this text and I can say that importing libraries and shift enter. So you can have the markdown text here. Next, we need to mount the drive. So to do it, first you need to put from google.colab import drive, and then drive.mount in brackets and in quotes you can put //content/drive and shift enter. So when you click on this one, it will ask you for the permission to connect to the drive. Connect it and then allow. So once it connects, you can see a blue tick here, and then we can access the data which we uploaded just now. So if I click on this folder, you can see the drive, expand it, my drive, ML projects, expand it, and this is where we go, this our simple linear regression project, and the data set is this one, student study hour version 2. So in the next line we need to read the data. To read the data, first I'll create a variable called df, it's a data frame, pd.read_csv, and in brackets we need the path to this folder, this file. So right click on this three dots and then copy the path and paste it here. Now shift enter. Now the data is read and stored in df. Then we'll do the normal analyzation. So let's take, if I put df.shape, shape is one of the properties of pandas. So run it and you can see it has got 28 rows and 2 columns. And if you want to check, you can always check here. See, you got 28 rows and 2 columns. Generally we don't work on just 28 rows. We'll be working on like 1000, 2000, 3000 in future projects. But if you work on real-time projects, it will be massive data and it won't be 2 columns. Rarely I heard anywhere we did any projects which work on like a simple linear regression. No, you can't depend. The target is never dependent on single variable or a single label data. Okay, but to understand and how to work on machine learning project, that's the reason we are using is single dependent and independent and dependent variables. So let's start the next thing. Once you get the shape, the next one is head method. If you run it, it will show the top 5 rows of the data, and then tail you can give 2, means then you can see the last 2 rows, right? Next, as we got something called info. Previously we did this one. Info is what it gives the information about the whole data. It says that it's a core data frame. When we do the next project where we'll be working on multi-linear regression, we'll work on it, and also more detailed information will be given in pandas playlist, which I'll be launching it soon. So let's get back on here, and if you see here, there are 2 rows, sorry, there are 2 columns. You can see hearts and scores, and null values are 28 and no null, means there is no row where there is an empty element is there. Means there is information in each and every row and column. So that is fine for us. Next, we can go for df dot describe, right? If you run it, describe gives us the relationship and the mathematical relationship between the numerical values. Generally, luckily, we have both the columns. We are working whether it's independent and dependent or numerical values, and that's the reason we are working on a regression problem. Regression problem is always numerical. Regression is depends on numerical values. And if you see here, the count is 28 and the mean of ours is 4.83, and whereas scores is 49.96. If you check on here, it gives the full information, the standard deviation, right? So let's jump on to the next level where we'll try to visualize the data. To visualize the data, we'll be using matplotlib. That's the reason we have imported matplotlib. So let's jump back here. We'll use plt.scatter. We'll use a scatter plot, and for x variable, which is generally for x, we work on a independent variable. That's the reason we'll use df, and in quotes it's hours, and whereas for dependent variable we'll be using scores, right? And we'll come back here, plt.show. By seeing this visualized image like the scatter plot, you can clearly see it's properly linearly linked. Means as you're spending more hours on study, you're getting more marks or more scores. So it's a linearly positive linear growth. That's good. So let's jump on to the next stage where we start dividing our data into two different variables. One is, right now we have only two columns, so one column, or else the independent column, we'll be calling it as x. So we can call it as x equals df.iloc. Okay, we'll be using the same method what we did previously, iloc, and here colon comma. First is about all the rows, means I'm saying that from the start to end everything I wanted, and then I'll put colon -1. What I'm saying is that leave the last row. Generally the independent variable, which or the independent we'll be using a matrix format. That's the reason we are using like this. But whereas if we go to the next one, which is the target variable, we can call it as iloc. Here I'll put every row, but rather than using colon -1, I'll just put -1. Means it will have only one column. So if I run it, the data is now in x and y. If you want to see, if you put x.shape, you will have 28 and 1. Whereas if you go for y shape, it will create 28 comma. Means this is a matrix and this is a vector. So this is one done. Means now we have the independent data in a separate variable and the dependent columns in the other variable. So next step is we need to divide this data into test and train data. Means where we can choose certain percentage of data to test our algorithm, and then train our algorithm, and then later we can test it. So let's jump on. To get that, to split our data, we need to go for from sklearn dot model selection import train and test split. Okay, now x train comma x test. If you see all the independent variables, we are starting the variable name with capital X, and if you see x train and x test is the same thing, but whereas the dependent I'm using y train, and y is in lowercase, and then y test equals train test variable x, y, and test size I'll be using 0.3. Okay, 0.3, and random size equals 0. Now something gone wrong. 10 expected a random size, random states, sorry, not size. See, that's the thing. Sometimes if IntelliSense sense doesn't work, see now it's working. So now we got our data split into test data and train data. So if you want to check, you can always check. Let's take, I'll put x train dot shape. So we got 19 rows selected in the train, whereas if I go for test, we will have the remaining 9 rows, because I'm going for y x test. But if I put y test and see the shape, I'll get only 9. Is you got it? Because this is x train and x test are x variables, which are the independent variables, and they are in matrix format, whereas the y test and y train and y test are in vector format. That's the reason we got this. So now we have divided the data. Now we'll work on creating our machine learning algorithm. As this is still in initial the basic beginnings, so we'll just still continue using. Okay, here we'll go for input logistic regression from sklearn.linear model input. So not logistic, sorry guys, it's linear regression. Logistic regression is I'm going for a classification, but right now because we are going for a linear model, it's numerical values, that's why we go for linear regression. And then I'll create LR equals, I'll create a linear regression. I create an object of linear regression called LR. So next step will fit LR.fit, will fit it with X train. Okay, we'll fit it with X train and Y train. Means we are giving the algorithm the independent variable and the dependent variable, means that 19 X trains and 19 Y trains are loaded here. Okay, done. Now our model is ready. So let's take, if I want to find the coefficient, if I point, I can find the coefficient, and if I want to find the intercept, I can find the intercept, because if you remember the equation is y equals mx plus c. So let's take I'm just predicting. Okay, let's take, rather than leaving this value, I'll put m equals, I'm storing this value and this in C. I'm rerunning it. So now y, I don't know why, but whereas m, I want to find if I study for 5 hours, okay, what will be my score? Can you see? My score is that I'm getting 50 plus. But let's take, if I work for 8 hours, I'm getting 80. Is it like this? But let's start doing some predictions. Okay, how to do the predictions is, you can put y underscore pred equals lr predict. Okay, lr predict on x test. We are predicting on x test. We know x y test values, but here we are predicting based on our algorithm. So let's see how close is our predictions. So I can call data frame, okay, and np.c underscore, and in brackets here I'll put x test, all right, y test, because these two things we know. Now the y pred is the one which we just now predicted. Also, after the bracket, we just put the box bracket, we put the columns. In columns also, once again, we'll put hours studied and comma, and in quotes I'll put scores. I'll put original score, okay, original score, and then also we'll put predicted score. So what it's saying, that if you study for 3.2 hours, original score was 27, and it's predicting that you should get 33 marks, slight difference. Whereas if you study for 3.8, 35 hours, 35 was original, but whereas if you are studying for only 1 hour, 1.1 hours, it's predict you got 17, but it's predicting that you should get. But as I said, that with the basic just 29 data, but still it's trying to come close to it. Let's plot the graph to see how we can see how this original data and the predicted data is related. So how to do it? So I'll put scatter plot, okay, I'll put x test, okay, rather than I'll put x train, okay, and y train. First I'm plotting the train data, so I'll put red color, and then I'll come out, because we do two plots, and then we can put plot here x train and lr.predict x train, because predictions are done based on x train only, okay, because we have trained our model based on x train. That's the reason we are putting the predictions on this one, and color will be blue. Oh God. Right, now what we'll just tidy up, we'll put plt.title, okay, and we'll put hours studied versus scores, okay. Then comes, you can put plt.x label. Here x label will be hours studied, and then y label will be scores, and then we'll show and if you see, these are the points, the dots are the original dots, and the best fit line is exactly, you can see it's nearly giving a good result. We'll see the score also, we'll see the score. We'll copy the same data, but this time I'll scatter the test and y test. Here once again plotting should be done based on x train by train only, because that is what we have trained. So let's see. See, these dots are our dots, means our test data, and the prediction was in this line. So it's really did a good job. Yeah, based on whatever we got, I think it did a good job. Also, we can see the score. Let's take, if I put LR dot score in brackets you can put x train. We are seeing the score of, okay, we are seeing the score of the training data. So let's take, we can see the same thing with our test data. LR dot score x test and y test. Here we got 94 point. Okay, so not bad, not bad. It has given us some decent results. Fine. Now let's add a little bit more to it. We'll use another sklearn matrix format, R2 score, which is which generally helps us to evaluate the performance of the linear regression model. It's called coefficient of determination. So how to use it? We'll call it as from sklearn dot matrix import R2 score. Okay, now shift enter, we imported that module. Now to use it, you call it as R2 score in brackets. Here you can test it on the test data and the prediction predicted, and we got 0.94, which is a very good result as per right now, based on one single dependent column and independent column and dependent column. So then you can use, how you can save this model, you can start predicting it. Let's take, if you see here, previously we did predicted using, we wrote this algorithm, equation y is equals to mx plus c with 8 years. So let's see, rather than doing all this equation, can we just lr dot predict, because we need to put matrix, so I'll put double boxes for list and then run it, and it is 80. And if you see here overall, yeah, it's the same. So it's working, it's giving me the result, and it's 0.94 score, R2 score. So good, based on a simple linear regression model, it's good. And you can always go back and check the previous lecture, which is the 101. We used it here. If you see, we also try to save it, export it as a linear regression model and all things. We can do it, but right now I think this is enough for you guys. Practice this one. In the next project, which will come within a couple of more days, like 5 days, we'll work on multiple linear regression, means where we'll be working on 2 or 3 independent columns and or labeled features and a target variable. That's it, guys. If you got any questions, any queries, please get back to me, or else keep practicing, and I'll see you soon with project 03. Take care, guys. Bye.